Hey, y'all. Today we are going to start talking about our probability unit. We're going to start with talking about random variables. So we have talked about randomness so far this year, where random is different than what we're used to. Random is when we know the possible outcomes, we just don't know which outcome we're going to get. And so we're going to talk about discrete random variables. That means variables with a limited number of outcomes, and we know all the outcomes. So we have this example of an insurance company where if you buy this insurance and you die or become permanently disabled, you'll get a $10,000 payout. I'm sorry, $10,000 if you die, $5,000 if you're permanently disabled, and it costs $50 a year. And so what we want to know is, like, is this profitable for the insurance company? And so the amount that the insurance company ends up having to pay out to one of its policyholders, we can consider a discrete random variable. There's a limited number of options. The policyholder could die, the policyholder could be permanently disabled, or the policyholder could be healthy and alive. And so those are the three possibilities. We don't know which one will happen, and they each come with a different cost to the company. And so we can create first what we call a probability model. And that's right here. Basically, we're just sort of laying out the options, the outcome when that option happens, and then the probability of that option. And so these probabilities, you might be wondering, hey, where did you get those numbers? Well, this is from the book, and they say from past data that about 1 in 1,000 policyholders dies, about 2 in 1,000 policyholders is permanently disabled, leaving about 997 out of 1,000 policyholders that neither die or become disabled. And this must have to do with some sort of job, I believe, where there's a risk of death and disability. And so we have the possible outcomes, what happens if those outcomes happen, and then the probability of those outcomes. And so if we want to figure out if this is sort of a lucrative policy to provide by the insurance company, we can calculate what is called an expected value. An expected, not inspected, sorry, an expected value, which we write E of X, is just a mean. So you should recognize that mean. It would be the mean of our probability model. And so this formula tells us to take all of the possible outcomes, multiply them by their probability, and then add them together. That's the sum symbol means to add all of these together. So we are going to take every outcome, $10,000 is our first one, and we're going to multiply it by the probability it happens. And then we are going to add to that our $5,000 if you are permanently disabled, and multiply that by its probability of happening. And then we are going to take our $0 if you remain happy, healthy, and alive, and multiply that by the probability of it happening. And I apologize, I'm experiencing some lag here, so if it looks a little choppy to you, it's choppy on my end. So we are going to make this calculation. I'm going to pause here and make that calculation. So if you made this calculation with me, you would get 20, and that means $20. And so what this $20 means is that the insurance company can expect on average here, not every time, not for every customer, but on average, they can expect to pay out $20 per customer. So each of these customers is paying $50 a month for the duration of their policy. And so if the insurance company is getting in $50 a month per customer, but they're only expecting to pay out $20 on average per customer, they're going to make a lot of money. Now, of course, they're not going to be paying $20 to any individual. For some people, they'll pay $10,000, and for some people, they'll pay $5,000. But there are so many people, approximately 997 out of 1,000. There are so many people who are going to pay $50 a month every month for the duration of this policy and never get any money back from the insurance company because they did not die and they were not permanently disabled, which is great. But they will basically just be paying for this insurance policy they never had to use, and therefore the insurance company will make lots and lots of money. So I want you to take a moment and I want you to read this question. So we have this scenario where we're drawing a card to try and get a discount at this Valentine's Day restaurant. And so we can have this probability distribution here, where if you pick the ace of hearts on the first try, you get a $20 discount, and there's a 1 in 4 chance of doing that. If you pick the ace of diamonds and then the ace of hearts, you get a $10 discount. There's a 1 in 12 probability of that, and we'll talk more about these probabilities as we go through this unit. And then if you select a black ace at any point, you just have to pay your full price, and there's a 2/3 probability of that. And so these are the only options. This is a discrete random variable. The outcomes are listed here, or the result of the outcome, how much discount you'll get. And these are the probabilities that those outcomes occur. And so we can calculate the expected value by multiplying all of these x's times the probability they happen. And so I would take my $20 and multiply by 1/4. Add to that my $10 multiplied by 1/12. Add to that my $0 multiplied by 2/3. And you probably are thinking, well, Mr. Pickard, if we multiply by 0, that goes away, much like in the previous problem, and you are correct. So take a second there and calculate the expected discount. This is going to be an expected discount per couple at this restaurant. So you should have gotten $5.83. We had to round there. We had a 3 repeating, but for practicality, this is $5.83. And what this means is the restaurant can expect on average, not for every customer, but on average, over the course of that night, to discount $5.83 per customer. Of course, some customers will get no discount. Some customers will get the $10 discount, and some will get the 20. But on average, about $5.83 of a discount because of their special. So that's sort of like the center of our probability distribution when we talk about a mean and expected value. So when we talked about distributions this year, we've talked about center and spread. The types of spread we can talk about here are both the variance, which we will denote as usually var, the variance of x. This capital X represents our random variable. So when you see that capital X, we're talking about a random variable. And the other spread we'll talk about is a standard deviation. And we'll refer to that or denote that as SD of our random variable X. And here's a note to say that the standard deviation is the square root of variance. So the standard deviation of our random variable is equal to the square root of the variance of our random variable. And that relationship is going to come into play in our next lesson when we start combining random variables. So we're going to calculate the variance similar to the expected value. And we're going to, we find the deviations. You can see here we have a new column to our probability distribution, our probability model, where we take X, that's each payout, and subtract our mean or our expected value that we calculated earlier of $20. This is for our insurance policy. So we take each possible payout, subtract our expected value, $20, and we get this thing called a deviation. And so we're going to take each of those deviations and we're going to square them. So my 9,980, I'm going to square it and multiply it by its likelihood of happening. This is very much like our expected value, except we have to find our deviations and then square them. And then my 4,980 squared multiplied by 2 over 1,000. And then add to that my negative 20. Be careful with that negative. The square of a negative is always positive. And that's times 997 over. So that term, that third term where you don't die or you don't become disabled, that's actually going to come into play here because this is not 0. So just be careful when you're squaring a negative number. And so when we make that calculation, we get 1,409 or 1,049 or 149,600. Sorry, I'm lagging. And so this number is not going to be super meaningful to us, this variance. This is a super big number. And so what we do is we take the square root of that and we look at the standard deviation. So we can take the square root of our variance. Again, I really apologize for the lagging. I don't know what's happening here. And we get $386.78. And so that seems a bit more like it. That's not so large. So the payout on average was going to be $20. And so we have this, the standard deviation means give or take $386.78 on average. So quite a large spread here and a small average payout. So the point here right now is to be able to calculate these values. We find the deviations, square those deviations, and then multiply them by the probability they happen. And so we can do the same thing with our discount. Remember that our expected value for our discount was $5.83. This actually brings that back up. So what I want you to do is pause here, and I want you to try and calculate the variance and standard deviation of our discount at the restaurant. So instead of making a new column, you can calculate the deviations within your calculation here. Just be careful, make sure you square those deviations. So I took my expected value or my possible discount minus my expected value we calculated for each of these. And this one's going to be negative, so just be careful. A negative squared is always going to be a positive result, so make sure that you put that in parentheses if you're putting this all into your calculator. And so we'll get a variance of $74 and approximately 31 cents. And if we square root that, we'll get a standard deviation of $8.62. So this restaurant can expect on average to give each couple a $5.83 discount with a standard deviation of $8.62. So maybe a little bit more, maybe a little bit less. And obviously some people will get 0, some will get 10, and some will get 20. So as always, make sure that if you did have a question while you were doing this, that you asked for help. Make sure you stick around and answer the questions at the end of the video. And if you need some help with those, please feel free. Take your time on these, and good luck.